Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 154, using Mohr circle to determine the maximum value of Ix prime and the corresponding value of use Mohr circle to determine the maximum value of Ix prime and the corresponding value of theta through the centroid, of course. So first, for our solution, let's divide the area into the following. So we have this division so that Ix is equal to, for this rectangle, 10 times 80 cube over 12 plus 2 times quantity 40. So this one is 40 base height 10, so 2 times quantity 40 times 10 cube over 12 plus area 400 times barred y, which is 35 square. So the distance of the centroid of this rectangular area, or that area there, from the XO-axis is 35. 40 minus half of 10, 5, so 35. IXO therefore is equal to 1.413 times 10 to the 6 mm to the fourth. While IYO here is 10 cube times 80 over 12 for this rectangle, plus 2 times 40 cube times 10 over 12 plus area 400, then barred x square, where barred x is 25. 20 plus 5. So IYO is equal to 10 cube times 80 over 12 plus 2 times quantity 40 cube times 10 over 12 plus area 400 times 25 square. So IYO is equal to 0.6133 times 10 to the 6 mm to the fourth. While the product of inertia for this center rectangle, it's 0. Then we use transfer formula. So if x is negative, for barred x is negative here, but barred y is positive. But for this case, barred x is positive, barred y is negative. So I'll just use this part. So PXOYO is equal to 2 times, with respect to the centroid, for this to 0. Of course, for the center rectangle, 0. Then plus area 400. This one, barred x is 25, barred y is negative 35. Then times 2. So product of inertia with respect to XOYO axis, negative 0.7 times 10 to the 6 mm to the fourth. We then plot 1.413, comma, negative 0.7 and 0.6133, comma, negative 0.7, so positive 0.7. So for the plotting, imagine that its graduation is 0.2, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4 here, 1.413, comma, negative 0.7. So this is the XO axis in this direction. And the other point is 0.6133, comma, zero point 0.7 there. So connect the 2 points with a straight line, which is the diameter of the Mohr circle. This is the XO axis, that's the YO axis. Then the circle. Then this is the center, which is half average of 1.413 plus 0.6133. So that's XOYO. And this is the center, 1.413 plus 0.6133 over 2. That would be 1.013 times 10 to the 6, of course. Then this is the XO axis. This is 1.413 minus 1.013. So this is the maximum moment of inertia, extreme right, Imax. Then this is the radius. This is 1.013 minus 1.413 minus 1.013, so zero point 0.4. Then we can compute the radius. This is 2 theta. 2 theta, so from the x-axis counterclockwise, from the xo-axis counterclockwise to locate x prime, or the u-axis. So that's 2 theta. R is equal to square root of zero point 0.4 square plus zero point 0.7 square. So the radius of the Mohr circle is 0.8062 times 10 to the 6. Then the maximum moment of inertia is center 1.013 plus radius 0.8062. So I max is equal to 1.819 times 10 to the 6 millimeters to the fourth. Then for the value of theta, tangent to theta counterclockwise, 0.7 over zero point 0.4. Then arctan of 0.7 over zero point 0.4 divided by 2, that's the value of theta. So theta is equal to 30.13 degrees. Level 155, use Mohr circle to determine the moment of inertia with respect to the u-axis and the maximum moment of inertia of the area and the corresponding direction. So we note that I already presented the solution to this for the moment of inertia with respect to the u-axis only. So for the maximum and the principal direction, not yet. So let's use Mohr circle here. So for our solution, Ix is equal to 12 times 6 cubed over 3, rectangle with respect to the base. So Ix is equal to 864 inches to the fourth. Iy is 12 cubed times 6 over 3. So it is equal to Iy is 3456 inches to the fourth. And the product of inertia is by transfer formula with respect to the centroid 0. Then area is 12 times 6. Barred x is 6. Barred y is 3 inches. So product of inertia is equal to 0 plus 12 times 6 area. Then barred x 6. Barred y 3. 1296 inches to the fourth. Then we plot Ix 864, comma 1296 and 3456 and negative of 1296. So let's plot it on the diagram shown. Imagine that each graduation is 500. So 864 comma 1296 would be there. Then the other one 3496, 1, 2, 3496 somewhere here. Then negative 1296. So connect the 2 points with the straight line, which is the diameter of the Mohr circle, and draw the circle. That's the x-axis. This is the y-axis here. And then the circle. And we locate the center as the average of 864 and 3456. So 864 plus 3456 divided by 2 is equal to 2160 inches to the fourth. Then 3496 minus 2160, or 2160 center minus 864 is equal to 1296 also. So that's also 1296 in this right triangle. Therefore, because the opposite and the adjacent are equal, the angle here is 45 degrees. To locate u from the x-axis, which is this, we rotate 2 times 30 degrees counterclockwise. So that's counterclockwise. 2 times 30 is 60 degrees. So this is the u-axis. And the angle there is 60 degrees, 2 times 30. and this is the radius. That's also the radius here. So that angle is 60 degrees towards the u-axis, while this angle towards the principal axis for minimum moment of inertia, that's 45 degrees, because the opposite and adjacent sides are equal to 1296. So that's 45 degrees. By the way, that's 60 degrees, and this angle here is 45 degrees shown. So for radius, so therefore 60 degrees minus 60 degrees minus 45 degrees is 15 degrees. So that's why that's 15 degrees. And that is I sub u. And this is r cosine of 15 degrees to be subtracted from the center to 160 to get I sub u. So r is square root of 1296 square plus 1296 square. So the radius is equal to 1296 square root of 2 inches to the fourth. Then I sub u is equal to 2160 center minus r cosine of 15 degrees. So I sub u can now be computed. It is equal to 389.6 as before, inches to the fourth. Then for the maximum, it is center plus radius. Center plus radius to get the maximum moment of inertia. So that's a maximum moment of inertia. And it is equal to 2160, the center coordinate, plus radius. So I max is equal to 2160 plus the radius. And let's call this angle from the x-axis clockwise towards the axis where we get maximum moment of inertia, 2 theta 1. And 2 theta 1 is simply 180 degrees minus 45 degrees, that angle there. So I max is equal to center coordinate to 160 plus radius. Sorry if I mentioned minus. So it is plus because it is from the center then move to the right. So plus the radius. I max therefore is 3,993 inches to the fourth. Then 2 theta 1 is 180 degrees minus 45 degrees clockwise. Theta 1 is clockwise, and that's a negative angle. So theta 1 therefore is equal to 67.5 degrees clockwise, or you may finalize the answer as negative 67.5 degrees. It is understood clockwise. So that's it for this problem.